So we're live. Hey everyone, thank you for joining. And this is likely going to be our last webinar before the holiday. And today we have Junhe from our data platform team to talk about data orchestration at scale at Netflix with Maestro. So Junhe, would you like to take a few minutes, maybe introduce yourself to everyone?
Sure. Yeah. Thanks, Xinran, for the invite. And I'm Jun, a staff engineer in the big data orchestration team at Netflix. I have been Netflix for more than 5 years. Since I joined, I have been working in this domain. And about 3 years ago, we started this Maestro project and built this great workflow orchestrator at Netflix. Yep. So yeah, before Netflix, I was at like Airbnb for about 4 years. I have been worked in the like distributed systems, like Kafka, and also the search infrastructure too. Yeah.
Nice. I'm curious, Jun, what would you like to do in your spare time?
Yeah, I have two kids, like 8 years old boy and a 5 years old girl. They keep me busy, and so I usually in my spare time play with them, and also work in some open source projects like the Iceberg, Kudu, or yeah, some others. Yep.
Got it. So actually, I was looking at your LinkedIn profile. You also worked at Hulu for a bit, right?
Yeah, that's true. That's
So I'm curious, like from working in data in two different streaming services, what like differences or the similarity here? Just out of curiosity.
Oh yeah, the yeah, that's a great one. I started my career at Hulu and then joined Airbnb, then at Netflix. So for this like 10 years, I see the like evolution of the whole data domain and the technology advances, and there's a lot of new things, right? At Hulu, I've worked at Hadoop, like Kafka at that moment just appears, and then join Airbnb, then kind of bring up the Kafka, and then now at Netflix, Kafka is quite mature, and then look at those orchestration areas and trying to modernize that. I see that there's a very exciting changes in this domain, and now we are in the AI right stage, and then there are lots of new problems and challenges appears. That's very exciting. Yeah, I really uh, love working in this domain. Yeah.
Yeah, totally. I can resonate with that. And also another part is like when you're working with kind of different companies solving different data problem, it could be very interesting and see how your work come to life, especially when you work on like a consumer facing company. And also like the industry itself just evolves so fast, and you work with different new technology, new problem evolves, and there's new technology also comes out to solve those problems. uh, I mean, there's always like new challenges that keep you motivated at the same time. You know it's a lot to learn at the same time as well.
Definitely, yeah, definitely. But that's
Yeah.
a great thing, right? We don't lack of problems. We just need the solutions, and yeah, that's wonderful.
Cool. I think it's a good time for us to get started with the presentation. So, Jane, please take it over from here and start your talk.
Cool, great. Okay, I start again. Hello, everyone. My name is Junhe. I'm a staff engineer in the data platform at Netflix. It's my pleasure to give this presentation today. My team at Netflix builds and operates Netflix workflow orchestrator, which is called Maestro. That I'm going to talk about it today. So at Netflix, all the big data platform users use it to build their data workflows. It's a robust foundation to build a large-scale workflow for machine learning and data ETLs. So in this talk, I will share our experiences and the lessons we learned, including patterns we developed and approaches we took at Netflix. Okay. Let's talk about the landscape of the data pipelines at Netflix first. Netflix is a data-driven company. Many decisions at Netflix are driven entirely by data insights, like from the color used in the landing page to upcoming original content. Data scientists, engineers, and even content producers all run their data or machine learning workflows to get insights they need. As our business scales globally, it relies on data to power its business in all phases. The scalability and the stability of the workflow orchestrator has become very important for the company. We also need to support a wide variety of use cases. Users use Maestro to automate their normal ETL pipelines, train their machine learning models, run A/B testings, and so on. Over the past years, we have developed this scalable and user-friendly orchestrator to provide users a consistent way to manage and automate their workflows at Netflix. So Maestro is our homemade workflow orchestrator. It provides workflows as a service to thousands of Netflix internal users. Users write their business logic, and then the Maestro is responsible to manage the life cycle of that. It's scalable and reliable, including multiple components, for example, workflow engine, UI, alerting, error classification, and so on. It also provides abstraction layers such as domain-specific language, DSL, and templates to be user-friendly. It satisfies all the needs of Netflix users and including engineers and even non-engineers. Here we try to abstract the common functions and reusable patterns from many use cases and add them to the Maestro in a loosely coupled way so everyone can get benefit from it. Also, triggering functions are also important. Users can schedule the workflow based on time, like providing a chronic expression, or based on the data signals, like running ETL pipelines once the upstream table partition is ready. Security is another important feature to protect users and our data warehouse. I will go over all those features and patterns in this talk. Okay, you may ask why we build our own workflow orchestrator instead of using some existing solutions. This decision is mainly due to the challenges we are facing at Netflix, which are the scalability and the usability. This graph shows our current scale. The growth rate is quite high, you can see, and we observe like a big increase every year. Maestro runs like tens of thousands of workflows and executes some million jobs every day. The load is uneven and the spike is high, especially during the start of hour or like midnight. So when we started the Maestro project about like 3 years ago, we were unable to find a viable solution. It's not only the number of workflows to manage in the platform, but also the size of a single workflow. So at Netflix, a single workflow might launch hundreds of thousands or even millions of jobs within it, which is a common in like a machine learning model training pipeline or like a data backfill pipelines. So we did not find a good existing solution for that kind of scale. In terms of usability, we have more than 1,000 unique users developing production workflows on Maestro. Therefore, usability is also critically important for users to build the robust data pipelines. As I said, our users may have different backgrounds. For example, some can write SQL, some can write Python, and some can write like Scala. After checking the existing solutions, we have decided to build our own orchestrator to support all use cases. Okay, because Maestro solved both challenges, it worked quite well to support a wide variety of use cases. Users use it to automate their normal daily or hourly ETL pipelines, like run their Spark jobs, Trino jobs, backfill data, and so on. There are also some specialized pipelines developed above Maestro. For example, we have an open source machine learning framework called Metaflow, which is also seamlessly integrated with Maestro. All production Metaflow workflows run on the Maestro. Other teams also build their services or their products by leveraging Maestro to handle the async tasks. For example, A/B testing workflows, payment pipelines, or simple workflows to move data between different data sources, like a Google spreadsheet to iceberg table, and so on. And then Maestro becomes the pivot path to access the data warehouse and run batch jobs at Netflix. Okay, let's get started with an example. So the task for us here is to create a daily workflow to get the total number of current active Netflix members. So we can create a workflow using like any editor you like, and then write this kind of YAML using the YAML DSL. Here, the trigger section defines a cron schedule to run this workflow every day at the UTC midnight. Then we give a unique ID, workflow ID to this workflow. Next, we define a workflow parameter called myQuery to hold the SQL statement we would like to run. Finally, we define a Spark job to run this query. We save it and then push it using the schedule CLI command line tool, and then run it using it. So in the test run, we can use a dummy query, just select one, to quickly execute the pipeline end-to-end to make sure it works without actually running an expensive query to go over the real data. So once we make sure the DAG engine, everything looks good, then we can actually run it for the production query. Then you can see once we schedule run the workflow, the response will show the UI link of the workflow. So I hope this example shows how simple and powerful it is for users to work with the big data by using Maestro. But there are lots of things actually happening behind the scene, which are transparent to the end users. Those are complex. Those are the complexity we would like to hide from users, so users can focus on developing their business logic and let the platform to handle all those like complexities. Here is a high-level architecture diagram. Our users use UI or CLI or client libraries to interact with Maestro APIs over the gateway, which provides a public abstraction and hide internal details. The engine is the core, which manages the workflow versioning, the state of the workflow execution, and so on. It also supports the scheduling with trigger components like a time-based trigger or event-driven. It runs like user business logic in Docker containers over the execution engine. The core is loosely coupled with downstream services by sending state changes to an event stream or to the Kafka. So the subscribers can listen to that. Here, I put a link to our blog. You can check that. It has all the technical details about Maestro. Here is a list of the key features that Maestro provides to our users. I will cover all of them in the following slides. It supports the DAG pattern with additional popular constructs, including sub-workflow for each and so on. It might be not exactly fit to DAG. For example, for each might be considered as a cycle, but we model it or model them in a way to support those within the DAG. Those constructs are super powerful and useful to help many practical use cases. I will show that later. Also, Maestro supports parameterized workflows, code injection, and so on. There's lots of features, at least here. We are going to talk about them one by one. As I have shown in the previous example, in addition to the UI support, we also provide a CLI command line interface for users to integrate with Maestro in the code, the terminal, Jenkins, everywhere. It's installable anywhere, meaning that the users can actually install those on their laptop, servers, dev environment, Docker containers, and so on. It's integrated with Netflix platform, including security too. When a workflow is created, the workflow is shipped together with the user identity. It also provides access management if you need to ship a jar or SQL file, or even encrypt a file that you need to decrypt during the execution time. This tool allows user to do that. It takes care of that in a seamless manner. Here list all the functions like push, run, activate, deactivate info. Yeah, so this is quite helpful. Next, Maestro DSLs, right? Domain-specific languages are the tools we are building in order for users to have a simple and abstract way to define workflows. We found that a human-readable DSL is very helpful and plays an important role to support the different use cases. At Netflix, users can write their workflow definition using DSLs in YAML, Python, or Java. The YAML DSL is actually the most popular one due to its simplicity and easy to understand. Here is another example of the YAML DSL defined workflow. It consists of two jobs. Job one runs Spark job, while users can put a SQL query or jar file the path there. Job 2 runs a notebook job. The users need to provide a URL or a path to the notebook, so Maestro can find that notebook on execution time. So we can see that users are not exposed to the internal of the execution of a particular job. They do not need to worry about how to communicate with one of the computer clusters. All they have to do is pick the job type they want to execute and provide the right parameters for their business logic. Also, if there's a bug, a fix, or enhancement for certain job types, we can apply it to all the jobs immediately. Users do not need to re-push their workflow again. So this provides like a readability, so anyone can read this. No need to read business logic, source code. Then you can understand how workflow should look like, right? And also reproducibility, because the scheduler keeps a snapshot of the input parameters and then pass it into the snapshot of the business logic, here like a Docker image or notebook template. So users expect to get the same behavior while restarting it. They can even like clone it and then run it locally to debug and troubleshoot, which means that we got a debuggability as well. And moreover, users write the workflow definition using those DSLs, right, which is the source code kind of for the users. Actual definition in the Maestro is actually the compiled definition. Therefore, with this design, we can do massive migration by changing the compiled definition without asking users to make any change in their workflow definition or business logic. Then we can move users behind the scene, for example, from like one system to another system without asking user to make a change in their workflow definition YAML. Okay, this is the same workflow defined in the Python DSL and also the Java DSL. Okay, as I showed in the architectural diagram, there is a dedicated single service to handle the single matching and the triggering. A single is a piece of information which can carry some parameters to run a new workflow. Also, step can define step dependency to wait for single to be ready. Both will be super helpful in many cases, which I will talk about later. Next, I will focus on the workflow engine, which is the core of the system, talk about its design and the technical decisions we made to serve our users best. First item is about our decision to build an engine including many useful patterns. So if we only support the core DAG features, we could reduce the complexity and make the code well optimized. But it means we will push the work to all the users and ask users to repeatedly write the same logic or find a workaround. This might mean like need like thousands of ways to solve the same problem. It's much better to support users with common patterns than asking them to do it by themselves. I use for each as an example. It's very popular pattern. Users use it to repeatedly run the same job with different parameters, such as like backfill data or hyperparameter tuning. We might ask users to explicitly define each iterations in the definition, which is tedious and time-consuming for large iterations. Just think about like hundreds or thousands of iterations. Also, they need to create new workflows if the for each range changes. So here is how we make for each fit to DAG pattern in a scalable way. So in Maestro, for each itself is a step in the original workflow definition. So each for each iteration is internally treated as another workflow, which scales similarly as any other Maestro workflow based on the number of step execution in the for each loop. So the execution of sub-DAG within the for each will be dedicated to a separate workflow instance. So for each step, we'll then just monitor and collect the status of those for each workflow instances, each of which manage the execution of one iteration. So with this direct engine support, users can provide an array of parameter values for each loop and jobs to run. They can change parameter value without a recreate workflow. System will handle that on behalf of user. Similarly, we add support of sub-workflow. Sub-workflow allows a workflow step to run another workflow and help to share the common functions across workflows. It's basically make workflow as a function and enables users to build a deck of workflows. For example, we actually have a very complex workflow consisting of 300 sub-workflows, listing with for each steps too. Okay, so we also support the continual branching, which allows running some steps only if the condition is true. So directly support those patterns in the engine enables us to optimize those features and provide a consistent way to realize those patterns. Additionally, the DSL helps to reduce the complexity to use those patterns. So they are very powerful and easy to use. In Maestro, parameters play an important role. We have decided to support dynamic parameters with code injection, which is also super useful and powerful, and our users love it. Together with other features, it makes the workflow very dynamic. But with code injection, the security is a big concern. Also, users might write like a buggy code. For example, a user might intentionally write an infinite loop to create an array and then eventually crash the server. To solve those risks, we develop our own customized expression language parser to support code injection. So then during the syntax tree parsing, we add like validations to secure and protect the system. We could ask users to put the injected code inside of business logic instead of in the workflow definition. But this will put actual work to the user side and also couple user business logic with the workflow. Here is an example that our users use to validate and process parameter data within the workflow definition outside of the business logic. So their business logic will get a clean data. With this great parameter support, Maestro support parameterized workflows. So, the simplest workflow is kind of static workflow. It's simple, easy to use, but it's quite limited. Often users have to duplicate the same workflow many times due to very small changes. The complete dynamic workflow will be hard to manage and support. It's difficult to debug or troubleshoot as well, and also hard to share with others or to be reused by others. Parameterized workflow are initialized step by step at runtime based on user-defined parameters. It provides enough flexibility for users to control the execution at runtime. Yeah, user like it. It's easy to manage and troubleshoot, but also powerful enough for them to write workflows with rich functions. Okay. To further enhance the parameterized workflow, we support callable step execution, which returns output parameters from user execution back to the Maestro. I think Airflow also supports that over XCOM, but we don't allow jobs or tasks to write to the Maestro DB directly. Instead of it sends the data back over the API layer to reduce the security concerns. Here is an example of the backfill workflow with 3 steps. In step 1, it computes the backfill data range and return the parameter dates back to step 1. Next, for each step, use the dates from the step 1 to create for each iterations with the backfill jobs. Finally, in each backfill jobs, it gets the date, that parameter from the for each, and then backfills the data based on it. So here is how our end users or data engineer define this kind of a backfill workflow using the YAML DSL. It's simple and easy to understand for even like long engineers. So we just like define from date to date parameters, and then in the job 1, here is a no ops, just for the demo purpose. It generates an array from date to date. Interval is 1 day, and then user define a for each job where they loop over the date from step 1, and then pass that date into the backfill job, which is a notebook job with the argument date. So users can test it with a small data range, right? I can go just one day. Once it is production ready, they can then let it run for days or weeks to backfill years of data. With for each support, we have workflows running millions of jobs over a long period of time. This is widely used for machine learning workflows at Netflix. Okay. Next, I will talk about the execution control. What we found is that the simple concurrency control on a simple entity is not enough. Our users would like to control, for example, like how many workflows to run, how many steps within one workflow to run, how many steps across all workflows to run, and so on. This requires a multi-dimensional concurrency control. So we develop a tag-based approach for that. Users can put multiple tags on a step to throttle it. Also, user asks Maestro to automate the data pipelines, but also have enough control of the execution order. We provide some predefined run strategy. We don't offer low-level ones because it is rarely used and also actually cause more confusions to the user, so we just drop the support. Here are the predefined one. Sequential is to run workflow one at a time based on the first in, first out order. Strict sequential is to handle the unexpected job failures. That's a visual request from our users. So you can see from this example, if there are failures, the new execution will only be in queued but not run. So here, run 5 is failed at 5 a.m. Then later runs will be queued but won't run until someone manually flag it or restart it. Then the workflow execution will resume. This because usually like a failure means there's a bug or there's something wrong, right? So data engineer would like us to just pause the execution, let them manually check it before we can move forward. But they don't want to lose those kind of trigger or cron executions, so they ask us to just queue them. First only is to achieve the idempotency. So if there's existing running ones, the new run is skipped. Last only is to allow new run to cancel the current running one. It's useful if workflow always want to process the latest data. Parallel to allow multiple workflow instances to run at the same time. Yeah. Okay. It's also important to provide debuggability and surface errors for users to troubleshoot. Both will improve the user experience. For debuggability, we support the breakpoint to allow users to pause step in workflows. We also surface error information, execution timeline information, and milestones to help users troubleshoot the failures. Those information very helpful. It include like Spark link, all kinds of extra information and the logs file link. The user can easily like just click and visit those logs files to find out what's wrong. Also, we build system functions in other services like error classification service, alerting service, or data feed for analytical use cases. So this helps to separate concerns and make the whole platform more scalable and robust. If any of those services is offline, the workflow engine can still run normally. Okay, next, let's talk about the workflow triggers because this is important for any scheduler. Maestro supports time-based triggering, like a fuzzy cron, which helps to solve midnight traffic spike problems. Because you see that how easy user can write a workflow. They can put like a cron trigger with at daily kind of annotation to run the job or workflow at midnight. Because so many users doing that, so we see a huge spike at midnight because everyone just put daily, then they run like a 00 UTC or like a Pacific time, like midnight. And those kind of huge spike put a lot of pressure on the system. Although our system is very scalable, can support that well, but we just feel like there's a lot of like a spike there. we might like smooth the traffic a little bit, because this actually push the pressure to downstream system, eventually even to our for example, Kubernetes cluster, right? Trying to launch containers, they also get those kind of spikes. So this fuzzy cron is a function, is a feature that we trying to mitigate this problem to smooth the traffic a little bit across. Here, the example is 2 hours 30 minutes, which means that this daily workflow will run between the 00 to 0:30. This kind of window, we are going to randomly pick a time and then schedule the workflow to run at that time. And so this also we support multiple cron triggers as well. Time-based triggering is popular because it's simple and easy to manage. But sometimes it's not efficient. For example, a daily workflow should process the data when the data partition is ready, not always at midnight. Therefore, on top of the manual and time-based triggering, we also provide event-driven triggering. It's efficient and accurate. Don't waste the resources checking if it's ready to run. Also, instead of running hourly or daily, it executes the workflow when it has to. So, right side, there's a example which includes two groups of singles. The first group of single is defining two singles that says, I want to run this workflow when table A is updated, and when table B has a partition update too. So it's an end condition here. We are able to do this because singles in Maestro ecosystem are the interpretation of the events. So our platform is fully aware of events in the Netflix ecosystem. So we know when a table is updated, when a partition has landed, and so on. Additionally, we allow users to define custom singles. Here, it says run this workflow when an application called my app has announced a single called ABC. This is available for any application which can emit events. Then those events land to a single service which converted to a Maestro single. So also in the single, you can have the payload in this event. They can put a payload including source ABC, lame single ABC, and so on. So when those events get placed into our event string, we can turn them into single, and then it can be used to trigger a workflow execution where workflow can actually consume those payload from the single too. Okay, next I will talk about the step execution. For advanced users, they can always bake their business logic into the Docker image and then let Maestro to run the image with a custom entry point. So we also, as a platform, we provided some pre-baked images as a base image user can use. It already installed lots of dependencies there. We also provide something called template job types. Those types are built on top of Jupyter notebooks that we use as a template. On execution time, we inject parameters that have been provided by the users into the template. Maestro provides around 30 template job types, like a Trino job, Spark job, transport job. Transport job is to allow users to move data between different databases like RDS, Elasticsearch, Iceberg, reporting tools, data auditing tools, or bring your own notebook. There are around lots of new job types. Also, we allow users to or developers to define the new template job types as well. With a schema, we can embed that in the DSL as well, which can help users to use those new templates. Here is an example of the notebook step execution. Papermill is an open source tool that allows us to run notebooks in a headless manner without a notebook UI. We pass parameters to the notebook template as input, and then specify the output notebook path. So on the right side, that is notebook output. At the top, there's a cell called parameters. it is very helpful because users can see all the parameters that are getting injected into the notebook execution from the Maestro. So it's easier for users to understand what's happening. They can also see the rest of the execution of the code. It's readable. It's also reproducible and debuggable because users can download this notebook and run it locally and debug it locally. Then user can go back to their workflow definition and update it accordingly. So there is another nice feature in the step execution called step dependency or input sync load. So basically the workflow can execute until a job that has a step dependency. Here, the example says job X has two input sync loads, table A and the single ABC. And then once the workflow executes to the job X, it needs to check if both sync loads are ready or satisfied. If not, then this job X is going to wait for them. So they are kind of paused there until like the table update and the application actually emits both sync loads, then it can move forward. So usually user uses this together with a cron, so they can have like a cron trigger to start a workflow execution. So they can have some like a job to run first, but then for certain jobs they need to wait for the sync load to be ready to be able to execute. For example, this job actually need to process the partition of today's partition or yesterday's partition. If data is not ready, they cannot run, right? So, but you use a single trigger, they cannot achieve this because they may have other jobs they want to run to save the time. Instead of like waiting until data is ready, they run the whole workflow. They would like to run the workflow beforehand, finish some preparation steps or other jobs, time-consuming jobs, until they land to this job. Then they can like have a customized the input single to block the execution until the data dependency is satisfied. This input single can be specified per job, which means even in a single workflow, you may have like different input singles or input tables for different jobs. Okay. Additionally, job itself can emit singles that can be consumed by downstream, either to trigger workflow or to release a job that is waiting for single. So this is a great way to orchestrate jobs and workflows in a distributed manner. So any job can emit a single, which can become a dependency for another job in another workflow, or even become a trigger for another workflow to start a run of the execution. So it kind of make the workflow can talk with each other out of boundary of a single workflow entity. Okay. So in summary, from definition to execution, Maestro consists of multiple layers. All of them have been defined with clear separation of concerns. This has allowed us to provide a scalable and user-friendly platform for our users to build robust workflows at scale. Great. Thank you. It's QA. Any questions?
Yeah, thank you so much, Jing. That was a great presentation. So yeah, I do see that we have quite a few questions from LinkedIn. So there's one question here asking about is Maestro proprietary to Netflix? I think what she's talking about is like, is this open source if there's anybody else who can possibly use it outside of Netflix?
I see. Yeah, that's a good question. We are still this is something we are still considering. So we don't have ETA yet. So yeah, currently outside cannot access it.
Got it. Well, I would recommend you guys maybe stay up to date with Netflix Tech Blog. I'm sure that if one day Dreamstream decided to make it open source, they will announce it from there. Cool. One more question. This is a really good one. How does Maestro compare to Metaflow, which is also a framework for defining and automating ML pipeline, and also come from Netflix?
Yeah, that's a great question. So I think as I mentioned in the slides that actually all the Metaflow production workflows runs above the Maestro. So basically, Metaflow is a framework which allows user to define their machine learning training models easily. and the users can use those Metaflow annotation to annotate their jobs and doing things, right? Then once Metaflow has those user-defined work definition, we have a adapter internally. I believe in the open source community, they also have an adapter for others. For example, like a step function, right? Then that very thin layer adapter trying to translate that Metaflow workflow definition tag into the Maestro workflow definition. And then once they have that, they create a workflow in the Maestro. So then whenever users run the Metaflow workflow, they actually run on the Maestro system. Does that answer your question? Or is there any follow-up about this?
Let's see if there's any follow-up. We'll see on the comment section. One more question from Kevin. I believe the fuzzy parameter is a great option. Could you please elaborate more on that? How do you decide which workflow from a pool of workflows will execute when after setting the fuzzy parameter?
Okay, I believe the fuzzy parameter, you mean the fuzzy cron trigger, right? So in that case, let me see. So basically, the fuzzy cron trigger we introduced here is trying to like spread the spike into a small window or window that the user specifies. So to do that, we have two choices. One is that at any execution time, right, midnight UTC or something, we kind of decide how much longer delay we should wait every time randomly. Another way is that at the creation time, when we push this workflow, we know that when this workflow will be executed, suppose like midnight UTC midnight, then we can like generate a deterministic way based on like some we can create a seed based on some shard or like a UID information about the delay. With that, like a deterministic random delay, we add into the cron trigger together to actually schedule them. This gives us a good way to let the user know when will be your next run. Also, from system perspective, like as this random thing is across all the workflows we own, so we actually see the spread of the scheduled execution. So we actually go with the second way that we don't like randomly generate a fuzzy delay at the execution time for each execution. Instead of at the push time, we kind of trying to introduce some delays. So, but from then on, all the execution will still schedule every 24 hours for daily cases. So this can we can easily tell user what's your next execution will be. So user that's kind of what we do that. Also, like to be clear, we are not kind of took a look at pool workflows. They all run daily, and then trying to decide what's the optimal delay it should be. Instead, we just put some random delays there. As I said, like because we don't have actually the concern for the scaling issue, we just like help the downstream to like spread the traffic a little bit.
Got it. Thank you, Dre. There's actually one more question from Kevin. So, is there a continuous mode in Maestro?
Yeah, that's a good question. So, basically, in the Netflix, we also have the streaming pipelines, which runs the stream jobs. So for the usually for like if users would like run those like subscribe stream or Kafka event, they go with the stream pipeline. For the batch use cases, we also indeed see users ask if we can like continuously run the jobs, right? One way is that you can go with the Spark streaming, something like that. Another way is actually using the Maestro to do it. So the way is how it works is that you can see here for the output single. Basically, when you finish the execution, you can immediately single saying run it again, right? Then in the single trigger, you can actually specify say single name itself and the type like whatever, like a completion of the execution. Then this will actually allow users to run the workflow continuously. Of course, there are some caveat there. Like for example, if the step failed, right, the single won't be sent. Then all the execution will be stopped there. So it's we might consider actually add this kind of continuous execution mode into a Maestro in a more in a better way. But currently, that's the how a user can achieve that using the single.
Makes sense. There's a few more questions. Okay, this is a question with a lot of context here.
Okay, let me read it. So I have some question about Maestro. First, is Maestro that is the task of sending alerts on arrow, or it is inside the code used that has this task? So yeah, I will answer this one by one. So first, for this question, there are two ways to do that. We actually have users doing that both. First is that in their jobs, in their business logic, they can use some library to emit or send an email or sending alerts. Second is that okay, that's third way actually. Second is that they can use our predefined those job template, which can send events as well, alerts as well. But the most popular way at Netflix is actually over our alerting system. So user in their workflow definition, they can specify a section called like notification. They can say, oh, if there's a failure, then please page me or email me or something. And then they can put like the email address or page duty like a link or something there. Then when those things happen, right? Because when the Maestro execute the workflow, the step failed, and then any state change will have an event be sent out to the Kafka stream. Then our alerting service subscribe those streams and get this event, and then they know that users actually have this notification set up because this alerting service are going to make a get request from the Maestro, get the workflow definition and know what's that. Then they know this and they have all the alerting information from the notification block. Then they can actually assemble an email which has a template that platform build with the workflow information linked to the workflow, and also like we can carry some additional information like what's the on-call instruction that the user or on-call can follow to like remediate the error together in an email and send to the users. Because we build this as a service, a learning service, we can actually have some very complicated logic there too. For example, like a user can say, if this workflow doesn't succeed for the past 24 hours, send me an email or something like that. So basically, the routing service can like subscribe those events, and based on the information that the user asks, they actually can decide what to send. So this kind of will abstract the complexity of alerting to put into this alerting service. Okay, second question is same question on retries. Is it the duty of Maestro or the code itself? So both way. So in the code, user of course can catch error and retry, but we don't recommend that. We more because that's add a lot of complexity to users. Instead, we actually suggest user just throw error. Maestro will take care of it. Maestro currently has like two error types. One is user error, another is the platform error. So users can specify different retry policy for different error types. For the user error, usually user can retry like 5 or 10 times. They can put in those retry numbers in the YAML. And for the platform retry, we default like a retry 10 times. So if anything wrong in the platform level, say the like container service is down, Maestro will kind of retry it based on the expansion backup policy. And then we can like automatically recover from all those kind of platform errors. How those error, like user error or platform error are decided is based on an error classification service, which subscribe to events from the Maestro as well. So it kind of will know, oh, this job actually completes. If it failed, it's trying to fetch logs from the other places about this job, and then it kind of analyze the log, find out what's wrong problem, say it's out of memory, right? Then should not retry. It will tell user, it will tell Maestro don't retry. Then Maestro, even like user say retry twice, Maestro won't retry that. That also enables us to build some kind of auto remediation mechanism, where it means that if say this job is out of memory, then the error classification will actually get this information. Then Maestro knows this. Maestro will ask auto remediation service what I should do. Auto remediation service will say, okay, by looking at the history, and also other jobs too. For similar logic, if we increase the memory by like 50%, it will succeed. Then we are going to try once to see if that can work. This one kind of way helps us to reduce the burden on the user side to kind of manually restart jobs and doing things. Okay, Mr. maybe, but do you have this way to using workflow? If error on a task of a DAG, then cancel the application of the formal job. If error on a task of DAG, then cancel the application of the formal task. I'm not sure exactly what I mean, but basically, if the business logic already happened, of course, in certain cases, for example, if it's an iceberg write, you haven't commit, then you can drop this snapshot. So that can be done. But for certain cases, if you just send an HTTP for, say, change the watermark to the current time, right, or something like that, that might not be a good way to roll back. So for this kind of thing, we only provide like a basic primitives for how to help user to build that. Basically, in this scenario, you can imagine you have a job, then you can have another job which has a condition saying if the upstream job failed, please run this remediation job. And then this kind of conditional branch can will based on the status of the previous job, right, to decide if it should run or not. And then this remediation job itself can do whatever you mentioned here, the cancel application of the formal task there, if it's possible. So we leave this freedom for the user to kind of do that. But from that engine perspective, we don't know if this job is cancelable or not, or even it's idempotent or not. So we don't like kind of automatically do that. What do you think about event triggering at source versus triggering at the consumer level when needed? Event triggering at source versus triggering at the consumer level.
So I kind of want to add one point on the previous question. One thing that might be applicable here, but I'm not entirely sure if that's what he's asking about, is that we do have this WAP pattern that's applicable in a lot of the data engineering workflow, is that if the audit failed, then the data is not written to the production table. So, that could be like a case where if a later task failed, and then you do want to reward the previous task.
Yep. That's a great point. Yes, thanks, Xingyuan. Yeah. Basically, yeah, and then we have a pattern called write, audit, and publish, right? It's called like a wrap. So in that case, is basically we first trying to write the data to a iceberg snapshot, and then this snapshot won't be committed to the main branch. Then we run the audit jobs. If the audit jobs succeed, we then commit it and publish, which means that we announce it to the world that this partition is ready. And if it failed auditing, then this branch will be not committed, then which means actually the execution will be canceled in that sense. Yeah. Thanks, Xingyuan. That's a great point. Yeah. Okay, last part, event triggering at the source, triggering at consumer. So basically, you can see that if I understand correctly, triggering at the source means the source table somehow generate this kind of trigger. Triggering at the consumer means that the table producer itself actually be able to emit events. And I think we have both. Basically, for certain cases, like it's an application or it's a streaming table, they don't have workflow running. Then they have their Flink pipeline or something running, which after they finish the job, they use a library to announce the signal. And then in the other cases, when you have a workflow, your job finish, as I mentioned, like a web pattern as well, is that we have a job type to announce a signal, or you can use actually the output signal feature from the step as well to announce signal. That signal will also go through the system as well. So basically, whatever, from Maestro perspective, any signal will be the same, like just like a piece of data received at the schedule side, and then the source or the consumer both can like emit that.
Yeah, thank you, Jing. Just one more question here. One person is asking about what's the difference between Mesa and Maestro in terms of user experience and developer workflow?
Sure. So that's a great question. Mason and Maestro both are the more like the internal engine that we use to manage the workflows, and because as I mentioned, like we have those kind of different layers, like a DSL, the API gateway, and we kind of able to abstract the internal Mason or Maestro front end user in a way that the user can still write their workflow in the same way that even internally running the Mason or running the Maestro. They don't need to worry about that. As I mentioned in the migration from Mason to Maestro, we are able to compile all the user workflows right internally to the Maestro data format from the Mason to Maestro. So we actually don't ask a user to make any changes. Then we migrate like hundreds of thousands of workflows from Mason to Maestro behind the scene, and we don't even ask a user to make like a change. Um, the main difference between Mason and Maestro are the scalability. So basically, Mason is a single node system, and Maestro is actually horizontally scalable system. And we have the Mason and then first, which uh, serves our purpose well. Then we build abstraction layer above it. Then we quickly actually hit the wall of the scaling issue. Well, as I mentioned, it's not just like a number of workflows we have to execute because that can be easily sharded, right, to multiple instances. But trouble is that with even single workflow, uh, it may have like millions of jobs to manage. In those cases, then it becomes a burden for a single node to manage that because it has to load the whole deck, right, and then be able to figure out what's the next job to run. In those cases, Mason cannot support that. We even like need to artificially put some like a limit to the size of the jobs in a workflow to kind of keep the system stable. But that have to ask a user to break their big workflow into small workflows, bridge that over like sub-workflow kind of pattern. It worked, but not that great. Especially, I think it slows down users' productivity a lot. The engineers is like limited by the capability of the data platform system. So that motivates us to provide Maestro, develop this new system which is scalable, so we can remove that limit. Also, while we develop it, we add lots of new features there. Because we kind of fundamentally we rewrite it, we can like fundamentally correct lots of design issues and the internal like problems. So Maestro is much like stable and reliable and scalable than the Mason.
That's great, Drake. Thank you so much for answering all this question. I think that's everything. Well, we're almost on time, so Jane, thank you so much for such great presentation, and thank you everyone for joining. And we'll wrap up here.
Great, thank you, Xina. Yeah, thank you, everyone.
Yeah, bye everyone. Bye. Have a good day. Have a good weekend.